Good morning, everybody. My name is Simon Edwards. I'm a cybersecurity architect and a threat hunter and investigator. So where our previous colleague was showing you about the sort of tools that analysts use to try to find current threats, I'm one of the people that sits in front of the screens and actually does that. Trend Micro, making the world a safer place to exchange digital information. That quite sounds like a big title, but that's our company's mission. And really, one of the things I wanted to talk about today with big data was how you can turn big data into an opportunity and how we've managed to build a $1 billion plus company around using big data from a security perspective. So for those that don't know Trend, we're the biggest privately owned security company in the world. We've been going for 30 years this year, big celebration at the end of the year. And we turn over about $1.5 billion a year, something like that. So it's a big cash-rich company with a lot of employees. We've got something in the region of about 1,200 threat engineers across the world. And we are truly a global company. We're based out of Japan, but the family that owned it is out of Taiwan. We do huge operations across Europe and across the US and so forth. But behind all of this is big data. Big data we've been doing for the best part of about 14, 15 years, and we use it for many, many different applications that help us to understand where the threats are, to be able to communicate those to the customers, to be able to bake them into the products so that they can actually actively stop the threats. And so research and threat intelligence is very, very key to what we do. We have two particular organizations within that specifically dedicated to threat research. The Zero Day Initiative through DV Labs over in Austin, Texas, is the biggest bounty program for vulnerabilities in the world. So basically, we pay the hackers before the bad guys pay them for the vulnerabilities. And it often allows us to be able to get protection against the 0 days, particularly not so much, I mean, 0 days in the Microsoft world is obviously important. And typically, we can get protection for our customers about 70 days before they actually release a patch for something, because we found the vulnerability, we can put the protections in place, and then obviously we give it to Microsoft, and Microsoft goes and fixes the problem, and then everybody else knows about it. But where it really starts to come in is when we start talking about the industrial Internet of Things. So the first speaker this morning was talking very much about IoT. Well, there's also an IIoT. IoT would be, you know, the watches and the sort of kind of dumb devices, for want of a better way of putting it. Industrial IoT is the really important bits. They're the water pumps, the electricity grids, the things that if they go down, they take out half of national critical infrastructure as a process. And obviously, we've got a very, very good example of that that's happened in the last 12 months with WannaCry. WannaCry, the NHS got caught in the crossfire. Anybody that tells you that they were targeting the NHS is absolute rubbish. The only reason that the NHS really got hit badly, they had done an enormous job, most of the hospitals had done an enormously good job at trying to patch their systems. But a lot of their systems were very, very old. And it's particularly the systems that sit in unpatchable systems, MRI scanners, blood banks, these big, huge, multi-million-pound things that hospitals buy to keep us all safe and healthy. Unfortunately, sitting inside of that is an old-fashioned Windows PC that was relevant when they bought it 10 years ago, but it hasn't been changed, it hasn't been updated. Nobody wants to change or update it because the MRI scanner might stop working. And so these things were sitting there vulnerable. And when WannaCry came along, obviously it was a worm, it self-propagated, it went straight through all of these things and took out the hospital as a result of it. And one of the things that we've seen in a lot of hospitals now is that they're seeing IT as a governance issue to the hospital, not just an IT issue anymore, because it's about keeping the lights on in the hospital, and you know, security can have an impact on that. And so, you know, we start to look across these things. You know, it's not just about computers anymore, as the first speaker said. It's much more about all sorts of little things and devices, and they could be tiny little things, but they could be quite critical when it comes to security. And we're seeing lots of attacks targeting those devices at the moment. And so we have a whole bunch of different research teams that augment this and put this together. And it all sorts of comes together into something we call the Smart Protection Network. And the SPN is one of the biggest global knowledge bases in the world for threat intelligence. But we also do lots of other things in terms of responsible disclosure to industry, working with healthcare, as I mentioned earlier on, working with law enforcement. I know we've got some law enforcement people in the hall today. We do a lot of work to actually help catch the bad guys. Because you can have the best software in the world that can stop every attack, but if you can arrest the hacker that's behind it, you'd be amazed how fast the things drop down and the threats drop. A good example was Angular when that was taken down about 18 months, 2 years ago. The overall number of zero-day exploit kits that were being used just dropped like a stone by arresting one team of hackers. So, trying to work with the National Crime Agency, with Interpol, with the FBI, to actually arrest these guys is ultimately the only real way of mitigating the problem. And so we do the sort of traditional research. And if you guys are interested in this, there's some fantastic documents that we've done as part of our forward threat research team that looks at the different ways that things happen around the world. Threat actors operate in different types of environments. We know from a state threat actor point of view that certain countries are into more chaos and violence, whereas other countries are more into stealing intellectual property rights, and see if you can work out which one I'm talking about. But then you also see other things, like, for example, the way ransomware operates is different around the world. Quite beautifully, in Japan, ransomware doesn't actually encrypt files. It actually humiliates the person into paying, because honor is a really important thing in Japan. One of the ransomwares will basically say, you've just watched a whole bunch of porn for free, you have to pay us. And they pay. So the motivations change. In Brazil, it's much more about banking fraud. What else have we got on here? There's all sorts of different ones. Digital souks, for example, in the Middle East. Rather understandably, it's a lot more political motivation that tends to be driven out of the Middle East. And so as we look at different threat actors around the world, their motivations and the way that they do things differ. But ultimately, what it really comes down to is understanding the threats and being able to suck in, as we've talked about already today, being able to suck in as much information as humanly possible, or computerally possible, to be able to analyze that data and to make sense of it. And so if we look at our smart protection network, we've got over 250 million sensors supplying information into that. Now, that could be your desktop that's running Trend's antivirus product. It could be a bunch of honeypot nets that we're running around. It could be work that's sucking off information from certain particular types of sites around the world. So, for example, analyzing applications that are being put onto Android application sites, for example, stores, app stores, and things like that. And so out of this, we're analyzing about 3 trillion different threat queries every year. And that then sort of starts to propagate down. And we're finding around 6 billion unique threats every single year. Most malware nowadays only targets 1 or 2 machines. And so it is very unique. In the old days, you picked up one piece over here, everybody would know about it everywhere else. But if that piece of malware is only being used once or twice on sites, then you've got a problem. We did an investigation the other day. The guy from Logarithm was referring to VirusTotal, and we often look to VirusTotal as a cross-reference point. VirusTotal is a site that Google maintains that allows all security information around the world to be put in. So you can put in the file hash, and it will tell you whether it's been picked up by different antivirus scanners and things like that. But the problem is, when we're doing investigations, we often find DLLs or executables that have never, ever appeared on VirusTotal. An investigation I did recently, we found 6 DLLs, all of which we knew had infected that machine 18 months previously. None of it was on VirusTotal. So don't rely on VirusTotal. VirusTotal is good for the known knowns, but it's absolutely useless for the unknown knowns because nobody's published it up there. And so you need some other way of being able to do this. And what it really drops down to is this ability to be able to understand where the threats are, understand when a bad domain or a URL is up, because again, that might only be up for an hour or two, and then be able to dynamically block it for our customers. So how do we do this? Because it's an enormous task. And how we do it is with machine learning and big data analysis. And as I said, we've been doing this for quite a long time. We have the Smart Protection Network. We have 25 to 30 years experience of working in this. But we also have machine learning practitioners with over 10 years of experience. We have a huge team of data scientists that understand the algorithms and understand how to do it. But as we understand it, it's about, and you'll hear this being repeated over and over again today, I assume, you start off with the data, You then start to build feature sets around that to understand what we're looking for. You then build algorithms that then start to bring those feature sets together until you create clusters and you create models. And then you can say, right, that cluster over there is Kerber, that one over there is Locky, and so forth. And so by understanding this, you can say, right, okay, so for example, pre-execution machine learning is a new technique that we've just put into our anti-malware products, where when an executable loads up, it makes a bunch of opcode calls. So it calls out to DLLs, it calls out to registry keys and things like that. And so what we know that certain sorts of DLLs tend to be called at for certain types of ransomware. So even if we haven't seen that version of ransomware before, we understand that the behavior with which it's operating, before it's even started to encrypt any files, the behavior is very, very similar to what we've seen in other samples, and therefore we can make an estimation to say we think there's a 70% chance that that is Kerber ransomware. And Kerber's a good example of this because Kerber, the landing sites that Kerber uses mutates every 15 seconds. So every 15 seconds you get a new version of Kerber that has never been seen anywhere in the world before. But it still has behaviors like all the other samples that it did. So using machine learning is a really good way of being able to understand whether what I'm seeing now is similar to something I've seen before. And so when we look at this from a cybersecurity point of view, the guy from Logarithm earlier on did the kill chain. So the kill chain is something that we all work within security, but it's about understanding the life cycle of an attack. And obviously, an attack starts with the penetration or the point of entry. Somehow, that attack has got to come in. And, you know, with things like ransomware, 70–80% of it's email. If you want to go away from here and really try and solve an immediate thing and get a huge satisfaction straight back from it, start sandboxing your emails as they come in. Do proper analysis on the URLs and file attachments of all emails coming in, and you will see just how many of them are missed by traditional security controls, but are being picked up by using things like sandboxing technology. Once he's got into that network, he then needs to maintain control of it, and so that means he needs to talk back out again. And so where there are many variations within the malware itself, the command and control structures that people use aren't very varied. They can use different dynamic URLs or dynamic DNS addresses, but ultimately they're all housed in the same place. And trying to create new command and control structures is expensive. And then depending on the type of attack, you'll then get lateral movement. And lateral movement is where I've infected that machine and I now want to move across through the network. Now, lateral movement is not something that tends to happen with, well, I suppose you can get it with banking Trojans. You certainly get it with ransomware, where it's trying to encrypt local file shares and network shares and things like that. But when you're dealing with advanced threat actors, serious state actors, lateral movement is all what they're after. Lateral movement is about, I want to get in here and I'm after a particular target. Interestingly, as we stand here in a university, we did a fascinating job just before Christmas for a very large university in the UK where we found foreign state actors were completely owning the place. I wouldn't want to speculate as to which country it was, but we're fairly sure we know who it was. But they had managed to remunerate the entire Active Directory system. They were stealing intellectual property on the research that was carried out in that university. It even resulted in a physical break-in, where some guy basically got into their computer room and stole 70 drives out of a 150 disk array so that they were able to rebuild the data. It was a very serious attack, and we managed to find it, identify it, and eventually kick them out. So, if we look at these sort of things, if we start with the penetration side of things, obviously we have exploits. So exploits can be network exploits, but they can also be exploits that lie within documents or within websites or malicious URLs that if I go off to that URL then it'll push something down onto my machine. Another interesting one we're talking about as well a lot at the moment is business email compromise. So what's business email compromise? This is where you attack the process within an organization. This is where you pretend, it's the scam email that pretends to be from the CEO that says to the accounts department, could you just pay this bank account £20,000, please? And you'd be amazed how successful it is. It really is very, very successful. And so coming up with, we've got a really quite fascinating new technology that's coming out called handwriting DNA that actually can work out the writing style of chief executives. The fact they can string a sentence together is usually a good starting point, but anyway. But we can understand the writing and how many times they press enter at the end and those sort of things. And then we can start to use machine learning to look for where we're seeing emails that doesn't fit to that writing style, where somebody's trying to emulate to be the chief executive or whatever. We then have the malware itself. So that could be process executable. It could be an executable file. It could be a DLL. It could be a script. A lot of what we're seeing at the moment is fileless malware. Fileless malware is where you're using, it's called living off the land, and it's where you're using the tools that exist within Windows to attack itself. Quite simply put, PowerShell. All right, this is where we send the PowerShell. PowerShell is now installed on every Windows 10 machine, and the hackers use that PowerShell to initiate, the exploit itself. And ultimately, what we're looking for is the command and control activity. And then when we talk about IoT security could obviously be anything. But at the moment, the big one is your own routers. Your own routers are under major attack at the moment. There's been the Myriad attack that was mentioned earlier. There's also been one that came out in the last week or so called VPN Filter, which infecting thousands of routers around the world. And quite a few were speculating that there was going to be an attack against the championship football last week, which didn't come to, which was good. And as I said before, we've got lateral movement. So to be able to detect lateral movement is really about understanding normal background activity on a network and understanding when it's not correct. So, you can see a remote logon from a separate machine coming into this machine. From machine A to machine B, I can see a remote login coming in. But is that a normal remote login? Is that part of BAU, business as usual process, or is that something unusual? And all of these are data points that can be sucked in and attempted to be used. So if we look at some specific examples, if we look at the networking security side of things first, one of the companies that we bought about 3 years ago now, something like that, Tipping Points. It's an intrusion prevention appliance that sits very much part of the network. It goes to blistering speeds and this sort of stuff. And this is where we got DV Labs from and that zero-day initiative research from. And from a networking perspective, what we're really doing is about analyzing terabytes and terabytes of network traffic to be able to understand what good looks like and what bad looks like. Being able to re-engineer the vulnerabilities so that we understand how to protect against that vulnerability, and we're not just writing a signature for the exploit. A lot of IPS signatures rely simply on trying to stop that particular variance of an exploit. And so for any given vulnerability, you might have 10, 20, 50 signatures that apply to it. We try to do it with one signature that looks straight for the vulnerability, and we do that by doing the vulnerability research in the first place. As I said earlier, we found more vulnerabilities in Microsoft last year than any other organization. If we start to sort of look up the stack a bit more and we look at the way that malware tends to come in, as I said before, weaponized documents is a really big attack vector. So this could be a macro file within a Word document. This could be a fileless malware attack where you can hide a bit of code into a CSV file. You load that CSV file up, it fires up Excel. Excel then calls to the PowerShell and does the job that you want it to do. And we've got a great proof of concept a colleague of mine was working on yesterday on this. But it could also be social engineering attacks. And we definitely see a lot of people being targeted in academia and within government using spear phishing attacks. We are all so dreadful about sharing information about ourselves. As the first speaker said, we post photos and God knows what else all over the place, and we're all as bad at it. Anybody that's watching my Facebook feed knows I'm in Edinburgh today. So, being able to use that and to utilize that for spear phishing attacks, for waterhole attacks. A waterhole attack is where if I know, and it's a good one for works for universities, if I know that all of the research fellows are going to a particular website for research purposes or discussion or whatever, I go and target that website and wait for them to come to me and then attack them, hence waterhole. And so we do a lot of work of analyzing files. We use sandboxing technologies, we use honeypot technologies and various others to try and capture these samples and then re-engineer them, and then we can produce indicators of compromise that allow us to go and find them. When there's a major attack in progress, I have to say as a threat researcher, one of the most exciting bits is trying to find that first sample. On that afternoon of when WannaCry hit a year ago, we were all panicking because it was coming through the mail gateways. You know, ransomware comes from email. Of course it does. Now, one of the things that Trend does is our software is used on the main NHS mail gateways. So, you know, if it had come through email, then it meant that we'd just missed something. And so there's a mad panic around, have we missed something? Have we missed something? As it happened, the NHS mail system was hit with a major ransomware attack that afternoon, but our systems repelled it. The problem with WannaCry was that it was a worm. And the last time, and I look around here at the age of you all, the last time worms happened was back in the late 90s, early 2000s. Most security researchers were still at school, probably still in their shorts when the last worm happened. They'd never seen it before. And it was only us old guys that had been around for a while that just started to go, well, hang on a minute, we're getting a lot of scanning activity on the network. This is a worm. And then we finally found the sample, and then by that means we all start moving with it. And we all know the story of Marcus Hutchins, who's fantastically found the kill switch, then stupidly went to DEFCON and is now, you know, incarcerated. Well, he's not actually incarcerated, but he's now stuck in America, unable to work or anything like that, because the FBI are about to potentially convict him for bad things he did when he was younger. So, you know, when trying to find these initial samples is really good fun from a researcher's point of view. But the more that we can use modern technologies and machine learning capabilities and things like that, obviously the easier it becomes. And then we look at websites and web itself, you know, in terms of phishing, in terms of malicious URLs. You know, we're monitoring or analyzing around 7 billion URL queries a day. And about 4.5 of those are malicious. 4.5 million of those are malicious. And so, and then the speed at which you've got to be able to find this. So every time one of our customers accesses a website, the software is making a lookup. If we've never seen that before, then we go and have a process that goes and checks it, does a web crawler, sees what's on it, checks the site, and then gives it a safe rating. And usually within about 7 or 8 minutes of that first website being seen, somebody globally, we will have an answer as to what the risk rating is according to it. And this is how we provide our protection for our customers. As we start to sort of get down into the point of execution, we then have, as is mentioned earlier on before, this concept of pre- and post-execution machine learning that we deploy at the local level. So it's managed to get through every single one of these security controls, and we're now executing that code. And as I said, the pre-execution machine learning looks to understand how it's operating and whether the way the opcodes it's calling to and things like that are similar to stuff we've seen before. And then there's also a post-execution machine learning, which looks at what it actually does. You know, if it suddenly tries to encrypt 20 files in the first 10 seconds, let's stop that, let's restore those files and kill the process off. And we found this to be incredibly successful at being able to detect that new genre of fileless malware. As we look at the control side of things, obviously malware to be successful, it needs to talk back home, it needs to dial back home and use command and control infrastructure of some sort. And here we use things like DGA algorithms. DGA is a domain generation algorithm, which is a way of being able to randomly generate a set of domain names, and then the hacker just registers one of them. It's incredibly difficult to stop, but by using machine learning capabilities, we can understand the behavior of domains and work out whether something is good or bad, and then be able to block against it accordingly. And then as we look into the IoT world, IoT is a major thing for Trend Micro. We are already working with car manufacturers over in Japan to create embedded security systems that will protect Panasonic entertainment systems. So you know within a car that the weakest link is the entertainment system because that's what's talking to the world. So effectively we've come up with a firewall and an IPS that will sit actually within the components of that. And we're working with a lot of manufacturers now to embed security directly in at the point of manufacture. Security by design, because it is the only way of doing it. You know, if you're trying to secure a random piece of device once it's come out of the factory, it's too late. You've got to do it at the earliest stages to it. And so we're doing a lot of work, as I said, around IoT-based intelligence, being able to detect Myria and these sort of things. And then finally, we look at lateral movement, and lateral movement is probably the most complex one that being able to determine. Because it's about understanding the behavior of connections. So if you look here, this is a sort of typical map of communication across an enterprise network. What we're looking for is to understand what good looks like so that we understand what bad looks like. So if you think about it in a corporate environment, you would typically, your workstations are only really ever talking to servers. They shouldn't really be talking to other workstations. There might be a few occasions, but generally speaking, not. Or if you're using Windows management, you'll typically have a WMI server or an update server that will then push the updates out to everybody else. So why am I seeing WMI being used from a normal user's machine? So it's understanding what good looks like so that we can then start to highlight in on what bad looks like. And as I said, it's about behavioral analysis. It's about collecting as much data as we can across the network so that we can then understand it. And then we can bring all this together so that we can provide information to customers that they can respond in much the same way as the guys from Logarithm were talking about. Providing a structure so that the analysts can make very quick decisions. There is no silver bullet to security. You should try to protect as much as you possibly can. But as was very nicely highlighted by the last speaker, there is a big move now towards understanding that detection and response is equally important. You're never going to stop everything. And so being able to understand and have the right threat intelligence at the right time to be able to determine what's good and bad is obviously what we're trying to achieve going forward. But the numbers, I think, are the real key to all of this, because today is about big data and it's about machine learning. We've talked about the various different ways that we can pull in threat intelligence, but the sort of numbers, we're talking telephone numbers in terms of the threat sources that are coming, billions of threat feeds coming in and trillions of pieces of information being sent back out again. You cannot do this manually. You have to use big data to do this with. And the world has jumped forward an enormous amount in the last 5 or 6 years in how we deal with databases. SIMS, the product that Logarithm was involved with, was always constrained enormously by a SQL database. They were held back for years because of SQL. The minute Hadoop came out, the gates were open, and suddenly they could do so much more because they could start to handle all of this enormous amounts of data and then create the right algorithms that sit over the top of it. And one of the things that we're working on at the moment is the next generation SOC. It's trying to come up. We know that the current technologies are very limited in this ability to handle enormous amounts of data. So how can we utilize the cloud? How can we utilize machine learning to create better threat intelligence? And then the other thing is also about how do you share this threat intelligence? Because I think this is something else you're going to see a lot over the next 4 to 5 years, is how we all need to share information and be a lot more acceptable about how we share information. And organizations like the National Cybersecurity Center are doing a good job at trying to get people to share, particularly within public sector, to be able to share information and so that, if to use the NHS, for example, if I see a targeted email coming in to a hospital in Fife, I want to be able to have that same threat intelligence being known instantly down to a hospital in Cornwall. And that is where we're all going to next, is making sure that threat intelligence is shared so we're reducing the duplication that's involved in it. So as I said before, these are some of the successes that we had last year. There were 3 trillion reputation queries from customers. We blocked 65 billion threats. We identified another 6 billion completely unique, never ever been seen before, and we blocked about 600 million ransomware attacks. Now that's 6 billion, you'd be amazed how many of those come from the NHS. The NHS is being targeted at about 3,500 unique attacks a week that have never been seen anywhere else. So, the strain that hits public sector, who don't have the money to invest at the best of times, same with the universities, same with county councils, the amount of county councils that are still using Windows 2003 servers to collect their council tax on. What could possibly go wrong? These are the challenges that exist, particularly within public sector today, but they also exist to enterprise as well. We've seen with GDPR over the last few weeks how organizations have panicked like hell and got it all completely wrong, and how half the US news sites aren't available to us anymore. Oh dear, we can't find out what Trump's up to. These are people just putting up walls to stop stuff. That's not going to solve the problem. Understanding about where users' data is and protecting it. GDPR is a fantastic thing if we all embrace it. However, front page of the Telegraph today, did you notice the European Commission has just been hit with a GDPR violation? Turns out they're not in scope. The European Commission does not fall under GDPR rules. There we go. So, Looking to the forward, we talked about the pre and post-execution machine learning. We're doing a lot of machine learning at the sandbox side of things now. We've built new systems that look at the reputation of domains and URLs. So if we see a URL that's only been, we already do it with files. So if you see a file, an executable file that's only been seen 4 times in Japan, it's probably not the real version. We can now do the same thing with domains and URLs as well. But probably the most exciting thing we're doing from a machine learning point of view is this writing style DNA, this ability to be able to understand different users' typing styles and then being able to understand when what we're seeing is not that. And then obviously trying to build the next generation SOC and looking at IoT devices. I think if there's one challenge for big data, it's getting the general public to understand it. It's getting the general public to not fear it. Because one of the most important things with big data is you need as much unbiased data as humanly possible that the analysts can then start to work with. And when we've got things like GDPR that's saying, right, okay, well, you cannot publicly identify people, then as long as those two work together, everything's good and happy. There's a big argument at the moment about the NHS getting access to use big data for cancer treatments. As long as it's not personally identifiable, this is a really, really, really good thing. They could reduce cancer detection rates down by weeks, months. This is a really good thing. It could save the NHS an enormous amount of money. But there is this whole feeling within the general public that, oh, well, they're using my data and Google's analyzing my data and, oh, it's going to get stolen or whatever. And so I think that us as big data practitioners, it is our responsibility to teach the general public about why big data can be a good thing. It can also be a dangerous thing. Let's not mess around. Threat actors are using big data analytics in the same way that we are using it for good. They're using it for malicious purposes. But when used right and used ethically, big data, machine learning can really, really bring great advantages. It can help build billion-dollar companies, but it can also help with research and reducing research down by months. So ultimately, we're talking about this 20 billion devices connected to the internet by 2025. It's all coming, but it's all going to be okay as long as we do it ethically and we go into it with our heads held high. That's me all done. I think we want to be breaking for coffee now, looking at yes, but we're in wherever the hell the vendors are. So if anybody would like to know more, come and have a chat with me afterwards. Otherwise, thank you very much.